today, the first thing we're going to do is review the idea of absolute value. You probably have done this in a previous math class, but if you don't remember or you haven't done it before, we're going to go over it. So the absolute value is the value of a number without regard to its sign, or the distance the number is from zero in either direction. So absolute value, you always get a positive or zero for your answer. It's not possible to get a negative for an absolute value problem. The symbol is like this. It's those two vertical bars around whatever you're trying to take the absolute value of. Before you apply the absolute value, the expression inside has to be simplified first. So let's take a look at these. We're going to take the absolute value for each one of these. So for this first one, first we simplify what's in the interior. That's negative 25.3. So its absolute value is 25.3. If we have 45 minus 7.7, remember that when you're doing that, you want to line up the decimals, so you're going to have to add a 0 after the 45 and do a little borrowing here. So that's going to be 3, that'll be 7, this will be 3. So it's the absolute value of 37.3. It's already positive, so it's just 37.3. Here, notice we have the opposite of the absolute value. You can read that as negative, but I think it makes more sense to do the opposite. You know, whatever we have after this, we're going to do the opposite. If it is positive, we're going to make it negative. If it is negative, we're going to make it positive. All right, 8 minus 81 is negative, what, 73? So the absolute value of negative 73 is positive 73. So my answer is negative 73. Do you guys remember how to do this when you have 8 minus 81? Does anyone not remember that? And it's fine if you don't remember. It's like, man, I've slept since then. I don't remember how to do that. Okay, so basically what's happening is you're starting at 8 and you're going 81 in this direction, right, to the left. So we want to go, well, where are we going to end up? Well, we know we're going to end up at a negative somewhere because 0 is right here. Okay? And we know this piece is 8. So to figure out how far this is from 0, what we can do is just do 81 minus 8. And that's 73. And that tells me we're going to be at negative 73. That's why we subtract these two. Sir?
Can you just start from 0 and then subtract?
Could you do what? No, go ahead. You can. What were you going to say?
I just started at 0 and went to 80 and subtracted 8 like that.
Okay. The other way you can do it is you can go, okay, starting at 0, if I go to negative 81, and then I go to the right 8, is that kind of how you're thinking about it? Yeah, absolutely. Where would that be? It would be at negative 73. So you're right. There's more than one way to think about that. And then here, 0 minus 3 is negative 3. The absolute value of negative 3 is positive 3. And I'm taking the opposite of that, so that's negative 3. Any questions? All right, let's move on then. So Sally lives in North Dakota, where the winter temperature is often below 0. One day, the thermometer read 10 degrees below zero, but it rapidly rose 15 degrees in 1 hour as a warm front moved in. Then it dropped 15 degrees as night fell. What's the resulting temperature? Where did she end up? Say it again. Yeah, 10 degrees below zero. Or at negative 15 degrees, so as I pointed out to you yesterday, the idea of things canceling out to make zeros is a really important idea in math. So what happens when Cecil the tightrope walker moves forward 5 feet and then back 5 feet? I'm sorry? Yeah. He ends where he started. The net result is he's moved, but the end result is he hasn't moved, right? His position is the same as it was to start with. So Chad decided to record Cecil's moves with the diagram at the right. So explain what you think the drawing means. Well, the pluses are movements which way? Forward. So the pluses are forward movement. While the minuses are backwards movement. So, using the same strategy, Chad recorded a different set of instructions for Cecil with the diagram shown at right. What could this diagram represent? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, move 9, let's assume that it's in feet, forward. Then 3 feet backwards. How long is the tightrope if these end at point B, which was the end of the tightrope? It's 6 feet. A really quick way to do that is go, oh, all of this motion doesn't really count, does it? 3 feet forward, 3 feet back, who cares? The end result is 6 feet forward. All right, in just a moment I'm going to give you a bag with some plus and minus tiles in it. You're going to reach into the bag, get a few of them, not all of them, and put them on your desk. Everybody's going to have your own bunch of plus and minus tiles. I want you to write out, just like we did here, how many pluses you have and how many minuses you have. Then find the value of your pile. Okay? All right. Because we're going to take a while for this, I'm going to stop the video.